So this week, we're going to play with section 10.4 on the book, which is about symmetry in 2 dimensions and in 3 dimensions. And there's a couple of kinds of symmetry that we're going to play with. I pulled some materials from Khan Academy, and then I pulled some stuff from our book and some other stuff just kind of out of my imagination, sort of, my past, to play with here. So when I think of symmetry, I think of a couple of different things. I think about lines I could draw through things to generate kind of a mirror image. And a butterfly feels like a very symmetric shape, okay? So I sketched a butterfly here, and I drew a line through the middle and marked where I thought that mirror image was. And so there's this idea of line symmetry. Go. Line symmetry. Line symmetry is also called reflective symmetry, so also known as AKA reflective symmetry. And some people are really good with this kind of thing and others aren't. And just, you know, we're all wired a little different. We all have different experiences. So I was always kind of very enamored since I was a little kid with symmetry. I think I was drawn toward it. I think most people are, but I don't know. And when I did sketches, my sketches tended to be drawings, you know, creative type stuff, tended to be very symmetric. And I had a hard time not being symmetric as a kid and as an adult. So this butterfly has one line of symmetry, and you have a line of symmetry if you can match points on each side. So for example, if I pick a point on this side of the butterfly, like maybe that point right there, I believe it has a symmetric point on the other side right there. And it is what we call line symmetry or reflective symmetry if when you connect those 2 points that you believe are symmetric, if you end up with a perpendicular line that connects the 2 points to the line of symmetry. So notice the line connecting the 2 points I believe to be symmetric. That connecting line forms a right angle with the line of symmetry. So this dotted line is the line of symmetry here. And let's see, I meant this other line to be green. Let's try to redraw that on top. Okay, and that line right there is just connecting 2 symmetric points. So put back on a pencil, yep. So connect symmetric points. And if you do indeed have a line of symmetry, when you connect symmetric points, you get a right angle. So those 2 lines have to meet at a right angle. Okay? If that's the case, you have a line of symmetry. If you have a line of symmetry, you have reflective symmetry. So let's take a look at some other objects here, and let's see what kind of symmetry they have. So I have a couple of points here which may be symmetric points depending on the line I draw. So in red, I'm going to draw what I believe is a line of symmetry. So let's start here-ish and head through there. So I think that right there is a line of symmetry. So let's just make a little note. Line of symmetry. Ooh, whoa, my pen went nuts there. My fingers. Question mark. And to test if that's a line of symmetry, what we do is we pick a pair of points that we believe to be symmetric about that line, and then we connect them. So if I connect these 2 points here, what should happen is that connecting line should meet the line of symmetry at a right angle. And that does appear to be the case. So that right there looks like a right angle. So that means this is a line of symmetry, connecting those 2 points right there. Okay. So can any line be a line of symmetry? The answer is no, not any line can be a line of symmetry. So let's take this butterfly, for example, to a new page and play with it. That's what I do. There we go. So does this butterfly have another line of symmetry? And I'm looking at this and like, well, maybe, I wonder if like through the middle here, I have a line of symmetry. So kind of rough guess oops, I wanted a different color there. Let's get red. So here-ish, maybe it needs to move down a little bit. So I would wonder, hey, is that a line of symmetry? Oops, will you let me move you? There we go. Maybe it goes up, maybe down, and well, if that was a line of symmetry, then this point up here should have a symmetric point on the other side, and it does not, right? So I can just kind of confirm that, yeah, no, this doesn't quite work, because I would want a symmetric point to that one. And what's symmetric to that? This point down here? No, it would have to be perpendicular. And there is nothing perpendicular through that line. So just double check. Not a line of symmetry. Okay. So, you know, you got to kind of play around to figure that out. Let's go back and check out some of these other figures. Let's see, does this figure over here have a line of symmetry? Let's see, well, I think it has. Let's see, anybody want to suggest a line I could draw? That looks like a hexagon. Giselle says, yeah. Okay, so I want to try and draw that line. Which way should I draw my line? Through the red shapes, maybe? Through the blue shapes, at an angle? Horizontal. So this horizontal or horizontal, like if I were to rotate this sucker? Thinking rotate there, or literally horizontal on the page. Through the top if you rotate it. So kind of like that there. Okay, so let me see if I'm getting what you mean. So I think you either mean something like this. I'm not sure I did the best job on that. I'll have to shift that a little bit. Will it let me shift it? Okay, so that looks like it could be a line of symmetry. And then just for fun, I'm gonna draw another one. I think if I come through here, that's another line of symmetry. And these two lines of symmetry meet at right angles. That doesn't have to happen. The other way. So this, the second one I drew here, Giselle, is what you were thinking?
Yeah, that second one.
Okay. Yeah, so it looks like I have two lines of symmetry, and then I could kind of play around to see if I have any others. So I'm pretty sure I'm just going to make a little note here. This one right here looks like two lines of symmetry. All right, so let's bring that to a new page just for fun. Play with it a little more. And sometimes it's pretty obvious about the lines of symmetry, and other times it's not. I got to really think about it. And it just kind of depends on the shape. So new page, paste that sucker in, and I think I have a rotation tool. Yeah, so let's move you up here and let's blow you up. Oops, I missed. Blow you up a touch. And sometimes we like it when things, it's not letting me do exactly the angle I want. Kind of snapping into place. Damn you. I guess I should have tried to draw it better. All right, best I can do there. No, it's not perfect, but it's my best sketch there with that tool we had before. So yeah, so I saw that line, I saw this line here, and then I don't think there's any others. Like sometimes I want to draw lines of symmetry through vertices, but that doesn't always work. Like through this vertex to that vertex made one, but if I tried to say connect this vertex to that one, I don't think that's going to be a line of symmetry, and let's just prove that right now. So I get that right? Not bad. Okay, so is this a line of symmetry? Big question mark. If it is, then I should be able to pick a point on one side and find its symmetric point on the other. So let's use green for that. So if this red line's a line of symmetry, then there should be a symmetric point to that. So then I draw a line perpendicular, and that looks about perpendicular right there. And then exactly this same distance away from here to here on the other side, so I'm gonna, see, I don't have a good way to mark that. I'm bringing out a piece of paper and I'm holding it up to my screen. And so I think, according to my piece of paper, that the symmetric point would live right here. So my claim is the distance from here to there is the same as the distance from here to here, according to my paper measure on the screen, and there ain't no point up there, okay? So that means this right here is not a line of symmetry because at least one point violates that idea about the symmetric point. So not a line of symmetry. And again, for something to be a line of symmetry, for any point we pick, there should be a symmetric point such that when we connect those 2 points, we get a right angle between the line connecting them and what we believe the line of symmetry is, and the distance from the original point to the line of symmetry is the same as the distance from the line of symmetry to the other point. And that doesn't work, that ain't a point on this figure. So I think I could play with this all day, and I'm only going to find those 2 lines of symmetry we found back here. All right, let's try another one. What should we do? Should we do the pentagon here, or this funky thing over there? Funky thing or pentagram gone?
The weird one that's green and purple.
The funky thing, cool, okay. So that is me attempting to sketch COVID-19. I don't know why I drew it like that, but I did. All right, let's bring that to a new page so we can doodle on it without the interference of this other stuff. Copy, new page, paste. Okay. So lines of symmetry. So I'd like you to look at that for a minute and think, how many lines of symmetry might this sucker have? And then we'll draw them in and explore to see if there's any others maybe. So what do we think? Like before, a horizontal line of symmetry? So maybe here-ish. And so this line would be like a mirror reflecting what's on top to the bottom. Yeah, I buy that. And then it looks like there's a vertical line of symmetry, roughly a little off there. There. Oops. I think I'm going to be able to move this. Oh, there we go. Slightly better. Nope, not any better. Okay, anyway, it's approximately there. Could there be other lines of symmetry here? Okay, Giselle chimes in at 2. Josie? I'm going to pull those out for a sec, because I think I see at least one more. All right, let me see here. Line tool. I think there's a diagonal one coming through here. And, whoa, how did that happen? Interesting. I got this weird line thing there. Okay, so I'm going to try to draw the diagonal. I think this, is a line. Almost in the right spot. Okay, roughly there. I'm a little off. I don't think I can move it exactly the place I want it. I'll try. About right there. So can you see that? If we pick some point over here, so let's do that. Just double check this is a line of symmetry. Let's say that one right there. Let's see. Whoa, you can draw on my screen? Huh, I had no idea. Is that a setting in Zoom? It's got to be through Zoom because that's how you're connected to me. I didn't realize I had my screen. Huh, sorry, I got to divert for just a second. Who said that? That was Giselle. Chat, make co-host, put up a hold, remove. Huh. I didn't think that was possible unless I like specifically push some button to say, hey, you can draw on the screen. That's cool. All right, but dangerous. Oh my gosh. Is that you again, Giselle? Or are we being bombed here? Is that what it's called? Huh. Okay. So that's a setting I better watch out for. That could be dangerous. Okay, but you probably can't erase it. Can I erase it? Oh, you can erase it. Cool. Thank you. All right, so let's check out this line and maybe I'll let you play with the screen in a second. So if that's a symmetric point, then I should be able to draw a line over to the other side. Maybe I'll do yellow. So I want to go from that point, oops, that's not yellow. I want to be perpendicular. That looks roughly perpendicular. And then that would appear to be this, oops, over here is the point I'm looking for right there. And yeah, those 2 points look symmetric. So any point that I pick, let's switch to yellow, like if I point this point here on the circle, and then I draw a perpendicular line from there through what I believe is the line of symmetry, there should be a matching point on the other side so that these 2 points are equidistant from that line of symmetry there. And the symmetric line, the line of symmetry meets the intersecting line at a right angle. Yeah, okay, so it looks like this has 4 lines of symmetry. So let's bring some of these back in there and draw the last one. Actually, let's get rid of some stuff too. Maybe I want the eraser. Okay, back to the line tool. So somehow I got to get my diagonal line in there. Oops, wrong color. Nope. Undo. All right. Red for lines of symmetry, maybe there. Not quite right, but close. And the other one is here-ish. And I'm just gonna tweak them a little. All right. So a ruler on paper is a way easier way to draw this. Computer's a little trickier. So we've got that one there. And then this one here. And then this one there. Come on, get in the right spot, would you? There we go. And this one here. All right, so every figure is a little bit different. We got to kind of play around and figure out what's going on with this. But this one right here has 4 lines of symmetry. So let's say this was the first one I found. So that's line number 1. And then this was the second one I found, line number 2. And then I drew this one in number 3 and that one in number 4. And right, that's 4 going to the other side. So there are 4 lines of symmetry here. Okay. All right, so let's move along to another idea. Another idea related to lines of symmetry is rotational symmetry. Now, if I take this butterfly here and I rotate it, there we go. How far do I have to rotate it till it looks like it did originally, right? Well, there's a sideways butterfly, now an upside down butterfly, another sideways butterfly. I have to go 360 degrees before I get back to where I started. Okay, so this one doesn't have any rotational symmetry because I had to do a complete revolution before I got it back. If I take, for example, this guy over here, if I rotate that one, at 180 degrees, I should get the same shape again. So that's the same shape I started with after 180-degree rotation. And then if I do another 180, that just brings me back to where I started. Okay, so the original orientation of this thing was right here. And 180 rotation gives me the same thing. So if you have, so there's a relationship between lines of symmetry and rotational symmetry that we're going to explore in a minute. Let's see, this one over here, if I rotate it 45 degrees, it's not quite right. This was the original shape right there. So let me just bring that back. Let's make a copy of it. Copy and paste. All right. Move it over a little. All right, so that's the original shape, right? And any rotation I do at first doesn't match the one I started with. And up to 90 degrees, right, it has two lines of symmetry in the same directions, but that is not the same orientation as that right there. And so it's not till I get to 180, so again, that's the original rotation. It's not till I get to 180 degrees that I get the shape back I started with, okay? But what happened was this point right here ended up over there. So it's not exactly the same, but it looks the same. This figure over here, what kind of rotational symmetry does it have? So I would say just a note on this one right here. Let's do this in blue. The butterfly had no rotational symmetry. This one right here had 180-degree rotational symmetry. And this one up here also had 180-degree rotational symmetry. This one over here, how far do I have to rotate it till I get the screen, get the shape I started with? So, oops, wrong color. Undo, and then, okay, here we go, move tool. So I'm gonna make a copy of this, Control C, and then paste it. All right, so here's that shape. Let's just sit it right next to it there. And I'm gonna start rotating, and it's telling me the degree I'm rotating here. So I'm up to 20 degrees, it's still not the same. 30 degrees, not the same. 45 degrees, not the same. 50, 60, 70, 80, wham. At 90 degrees, I get the same shape. So when we talk about rotational symmetry, we usually mention the first angle that gives us back what we started. And it's not till I go from 0 to 90 that I get back to what I started. Now 180 also gives me what I started with, and so does 270 down here. And 360 really doesn't count because that's back to where you started anyway. Okay, so at 360 degrees, that's the same as no rotation, because this point right here, 360 gets back where it started. So this one has from this point to there is 90, and then over to here would be 180 and 270. So I would say this sucker has 90-degree rotational symmetry. That's the way we talk about it. Oops. So 90-degree rotational symmetry. All right, so I got some other shapes I want you to take a look at with me, see what you think. Here we go. So this is a little rotational symmetry exploration. I'd like you to help me identify the rotational symmetry of each of these figures. So rotational symmetry. And we make note of that by the first angle that gets us back to where we started. So note, first angle that gives back what you started with. Okay, so I got, Giselle says the first one is 180, started with, okay. So, sorry, 120. Okay, so let's see about that. I think you're right. And let's make a copy, oops. Copy of you so we can compare it down below. Okay, so put it underneath, and then we'll start rotating. So so again, I'm going to keep rotating until I get back exactly the orientation I have above. So 60, 30, 60, 90 doesn't work. Notice that's not the same. Keep going. 100, 110, 11, 12, 13, 120 looks like an identical match. Yep. Yeah. So this one did a 180 degree, sorry, a 120 degree rotation before we got back to what we got started with. So this point right here moved from way back here 120 degrees. Okay, the second one looks like 72. And let's see, copy and move. All right, so 72, so keep going, keep going, keep going, 70, oh, come on, stop right there, 72. And this is now out to the side, just like that. Yep, that looks like a 72 degree rotation to me too. So note that this point, oops, it's not a pen, this point right here came from down there. So that would be a 72 degree rotational symmetry. And then multiples of 72. So if we kept spinning that thing, so let's just grab another one for fun next to it. 72 plus 72 is 144. So 144 should also give me the same effect. Let's bring this down here and we'll try 144 and see if we get the same thing. So 130, 40, 1, 2, 3, 4. There we go. Yeah, and you can see this little doodad is sticking out to the right. This was the one I started with right there. Yeah. So this has multiple symmetries, but the smallest is 72, and that's how we usually name the rotational symmetry. Now, there is kind of a connection between these little nodule type things here. There's 1, 2, 3 nodules, and there's a relationship between a rotation 3 and 120. This one has 1, 2, 3, 4, 5 nodules, and there's a relationship between 5, 72, and a complete revolution, right? What's the relationship, do you think, between the number of times I can rotate and a complete rotation? And it's pretty straightforward. We come around here with 1 rotation, 2 rotations, and then 3 gets us back where we started. 360 divided by 3 is equal to 120, which is the earliest rotation we get to get the same shape we started with in the same orientation. This one right here would be 360 divided by 5 possible rotations there, which is the 72. And let's see, you believe this one is 30 degrees, so let's give that a shot. Oops. And do a 30-degree rotation on this sucker. All right, so come on, there we go. And so there's a couple ways to think about it, right? I could say this, I want to, when I have a nodule facing straight up, or I have a nodule facing out to the right, then we've done a rotation that gives us the same orientation we started with. So it doesn't seem to be happening any sooner than 30. Yeah, 30 is when I get the soonest one. Agreed. And let's just count up here on this one as we move around. Starting here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these nodules coming around. And if I take 360 and divide by 12, I get 12 goes into 36 3 times with a 0. There's that 30-degree rotational symmetry. Yep. Nailed it. Okay, the last one. What do you think about the last one? It looks like it should have rotational symmetry, but it's kind of a blend between this one here and that one there. Just a note on this one right here, this one had 12 outer nodules, and if you count these little purple circles on the inside, switch to yellow, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each circle inside corresponds to one of these nodules on the outside. But this one right here looks like it has the same number of nodules as that first one. So on the outside, it's got 12. Is nodule even a word? That's what I'm calling these things. But it only has 6 circles inside. So 6 circles inside. So what kind of rotational symmetry does that have? Let's see, did somebody pop up with something? We got third, not yet. The screen seems to be jumping around. Maybe it's the weather. Okay, so I want to make a copy of that. See if we can explore this. Oh. All right, so I want to try and rotate till I match what I have up there. So, oops. So start rotating, and I don't think it's going to happen any sooner than 30. So again, I'm thinking about like when that I get one pointing straight up or straight out to the right again. So let's move this, and at 30 degrees, right, I have this thing facing straight up, but do the circles match up? So let's see. The original has a nodule pointing straight out that way, and this has a nodule straight out. But the original has a circle straight out to the right, and this one does not. Okay, so Yazel chimes in with a 60-degree rotation, and I think you're right. I think it's going to be, oh, that was a pentagon. I don't have one like this, do I? I lied. Yeah, this is going to be more like a hexagonal rotational symmetry. So let's erase those markers. Actually, I can leave them there. And pointer tool. Let's continue the rotation. So I have 30 degrees already. I'm just going to continue till I get over to 60. And now I have both a nodule out to the right and a circle pointing out to the right. So, okay, so this one had a 60-degree rotation. So all of the pieces together have to be taken into consideration to identify it. So this one right here actually has a 60-degree rotational symmetry. Okay, so that brings us to our activity. Let's see, is there anything else I wanted to do? Yes, oops, I want to do something else before we do that. Let's see, how do we want to do this? I want to explore more the reflectional symmetry, and I'm going to do that with a little geometry and algebra. So I'm going to switch over to GeoGebra, not that one. Yeah, let's use this one right here, but I'm going to start over. So let's just delete you and go. Okay, so what I did was I just searched for GeoGebra. If you want to play along, GeoGebra. And if your internet's down, I'm sorry, you're just going to have to watch me for now and maybe try it later. And then I'm going to go for the classic this time. Is that true? No, I'll stick with the geometry, but I'm going to have to tweak it a little bit. All right, so I'm going to get the geometry one we played with a couple weeks ago. And I'm just going to adjust the way it looks because I want to see the grid in the background because I need to draw a special line here. So I want to show axes and I want to show grid with major grid lines should be good enough. Okay, so I'm at the GeoGebra geometry from their homepage, geometry. And then I went to the settings and I'm showing the axes and I chose to show the major grid lines. And let's see, snap to grid is on, which means if you get near one of these intersection points, the dot will kind of jump there if you get too close, like magnetic attraction. All right, so I'm just gonna move you down here, and I'm gonna draw a 45-degree line heading down. So I'm gonna say start at 5 and go down to -5. And you can do this with any line, but it turns out a 45-degree angle line is the easiest to do it through. So let's see, what I want to do is make a symmetric figure starting with a couple of points. So let's just pick a couple points here. Let's pick this point right here and that point right here. So let's say I want to make a quadrilateral that has this line of symmetry here. And so that's my goal here. I'm just going to take a screenshot and write that down. So we'll just grab this much, say. All right, so new page. So my goal here make a quadrilateral with points C and D where line AB is a line of symmetry, or a reflective symmetric line. I'm just going to call it a line of symmetry. So for that to happen, what I have to do is draw a perpendicular line from C through AB, and then find C's partner on the other side there. So coming from here, we have to head through at a right angle, which looks like about there. So again, I need to be pretty sure that this is a right angle. And then whatever this distance is from C to the line of symmetry, I need to match it out here. And that is one unit diagonal followed by a half of one. So a half followed by one. So out here should be, let's call that C prime, because that's C's partner point. And then the catch there is that, switch to green, this green distance here should match this red distance over here. So from C to the line is the same as C prime to the line, and the line connecting C and C prime are perpendicular. Okay, so line C, C prime is perpendicular to line AB. And in geometry notation, it's redundant to say line if I put the bar over the letters, because that bar means line, so I didn't have to write that, but just kind of speaking what I'm saying. And then C and C prime must be equidistant from line AB. In order for AB to a line of symmetry, these two things have to be true. Okay? And so that's where C prime comes from. And I have to do the same thing for D here. So from D, I've got to find the symmetric points where I'm perpendicular from D through line AB. So I have my right angle here. And then whatever distance D is from the line, I have to match that distance on the other side of the line through that perpendicular. So then it looks like this point right here should be my point D prime. And now I have my quadrilateral. And it would be C, oops, I'm gonna use the line tool. From C to D, from D to D prime, from D prime to C prime, and then C prime back to C. So this right here is my quadrilateral. So starting with the point CD and the line of symmetry AB, we found two other points so that we have that line of symmetry through the quadrilateral there. And again, I mentioned that if this was not at a 45-degree angle, it becomes much harder to find those opposite points. And so there's a couple of videos on this in Khan Academy and some problems you're going to try like this on Khan Academy. So I just wanted to do an extra example like this. And the book has a couple of examples like this too. All right, let's see. Let's take a look at the activity, and then that'll be it for today, and then we'll save a few things for next class. So show desktop, back to the home page. What do we got going on? So we'll get the activity started and finish it up next class. So we are in week 7 now. There's the reading, which hopefully you've done, and then the Khan Academy assignments, and I list out what I want you to do. I decided to grade this one a little bit different. I'm gonna grade you for watching the videos too. And the points I assign for the video is also the length of the video. So you get 3 points for watching a 3-minute video, you get 4 points for watching a 4-minute video. And Khan Academy shows me if you watch them or not. So last time I said skip the videos or watch them, it's up to you. This time I do want you to watch them. And the Khan Academy stuff covers 2/3 of this section, and the other third of this section is about 3-dimensional symmetries, which I'll talk about next class. But I didn't find any good Khan Academy stuff. And I'm not sure, I don't think there'll be any extra homework about the 3D stuff, but it is related to the next activity, which we'll talk about later. So there's a few videos I want you to watch: 3 minutes, 4 minutes, 3 minutes, 7 minutes, and you get points for watching them. And then 3 exercise sets with 4 questions, and 7 questions, for a total of videos and questions of 32 points. So please do that sometime soon. And let's take a look at the activity. All right, so we're going to continue playing with pattern blocks like we've done the last few weeks. They're just a fun tool for geometry. A lot of classrooms have them, and there's these online versions. I linked to the 2 I like lately. And some of these online apps come and go. Technology changes, so these aren't the same apps I used 2 or 3 years ago. And when you're a teacher, if you want something like this, maybe these things will still exist, and maybe somebody wrote a better version. We'll just wait and see. So what I want you to do is identify the lines of symmetry of each of these figures here. And I also want you to identify their rotational symmetries. So let's just walk through a couple of these together so you get an idea of what I want you to write up. So again, the point of here is we're just exploring ideas of lines of symmetry and rotational symmetry. And you need some pattern blocks, pattern block app. You're likely going to need paper and some colors to play around with, like I was on the screen. Here's the online apps if you want to mess with them. And so the first part of the activity is to identify the symmetries of each pattern block. And then the second part is you're going to create your own designs. And so down here, you can see that design I was playing with earlier that I played with, and then I talk about its lines of symmetry and I talk about its rotational symmetry. Alternative, I could put some sketches in here, and I'm going to do a little of both for these. So let's add this to my notebook. Okay. New page, please. All right, and we'll make it slightly bigger. And all right, so lines of symmetry here. So on a piece of paper, I would sketch my best hexagon and then start playing around with its lines of symmetry. So I'm going to attempt to draw you over here, hexagon. Let's say we're going to draw you in green. So we have line, line, line. Probably be better just to copy it, but you guys might have to draw this on paper, so I might as well try hard. That's not too bad. Okay. Okay, so that's symmetric to the best of my artistic ability at the moment. And lines of symmetry through this. So usually vertical and horizontal, if they exist, kind of jump out at me. So I would say there's one line right here through the middle, and I'm going to label it as 1. And then I think there's one, right, because mirror image, right, see the perpendicular nature of symmetric points. And you can pick any point on an object. It doesn't have to be a vertex, right? There's tons of points on these line segments. Okay, so that's one line of symmetry. I believe this, oops, wrong tool. I believe this is another line of symmetry roughly through there. So then I get symmetry. It's kind of a little bit different. So through the midpoints of those 2 sides is a line. Through these vertices is another line of symmetry. So I'm going to label that one number 2, and then I'm just going to start going around and drawing all the ones I see. So I guess there should be one through the midpoint of each side. So from here to that one, and then I get symmetric vertices from that line. So this would be number 3. Through this midpoint, I might as well stick with midpoints for now. Oops. That's about the midpoint, and that's the other midpoint. Not too bad. So this would be number 4 there. And let's see, midpoint, midpoint. I got the midpoints going around. Now I have to connect the vertices. And that doesn't always work, by the way. It depends on the figure. So this vertex to that vertex, I believe, gives me another line of symmetry. So that would be 5. Oops. And I think this is the only one I'm missing right there. So line tool. And every figure is different and requires, for me, great thought and concentration. Possibly some coffee. And I think there's 6 lines of symmetry there. Yep. As far as rotational symmetry goes, so this could be one. Otherwise, I would write a description of that if you didn't want to include that drawn picture. So what would my explanation of lines for this one? It might look something like this. Line through each vertex let's see, how do I describe that? So like this one right here, I want a line through that vertex, through the center to the opposite vertex. So line through vertex, through center to opposite vertex. And then I found there were 3 of these. All right, double check. I went from this vertex to that one, that was 1. I went from this vertex to that one, that was 2. And then this vertex to that one, that was the 3rd one. So there were 3 lines of symmetry through the vertices. And then there were 3 lines of symmetry through perpendicular bisectors of each side. And then another, and finding the language to explain, right? It's easier to just say, hey, look, there they are, okay? But describing it in words is a whole nother thing. And again, you're going to be teachers, so I highly recommend you draw the picture and try and explain it. So another 3 lines through perpendicular bisectors. Okay, and I think that's good enough. All right, so that gives me all of the lines. Picture here, show me how, and then tell me how. And then if somebody doesn't understand what I meant by perpendicular bisector, then I need to pick a different set of language, okay? So again, perpendicular bisector means bisect, cut in half, and then the line you use to cut it in half has to be perpendicular. Okay, so right angle. So this right here is then a perpendicular bisector. Of that line, this line here, and that line there, that line segment there. All right, rotational symmetries. I think the earliest rotation is to get this point right here. Let's put a little star, that point right there. Oops, I want to use green maybe. That point right here. If I rotate up so it lands here, what angle is that? Well, I can do that 1, 2, 3, 4, 5, 6 times before I get back to where I started. So 360 divided by 6, 6 goes into 36, 6 times with a 0. It looks like the soonest I get the same shape is a 60-degree rotation. Okay. So 60-degree rotational symmetry, since there are, I think, how would I describe that? I think it's just because these interior angles are all the same. Yeah, no, that's not enough. Why do I say it's not enough? Because, let's go back here. This angle right there is the same as that angle there, that angle there, that angle there, that angle there, and that angle there. And this sucker right here did not have 60-degree rotational symmetry. This had 90, nope, not even 90. This had 180-degree rotational symmetry. Interesting. So as you walk through this, oops, wrong button. you might think back on previous things you wrote or said to see if they make sense with respect to other shapes. Okay, so as I was trying to describe why, I was just thinking about the interior angles being the same, but then I remembered that other shape, and that wasn't the case on that one. So I think this is because it's regular, that it has both it's both equiangular and equilateral. Okay, so since there are equal angles, and line segments, or edges maybe. Yeah, so coming up with a why is definitely the trickier part. Showing somebody is easier, okay, and that's always going to be the case. And we have to bounce back and forth between them. All right, I think this went on for long enough. So again, for each of these shapes, what you want to do is identify the lines of symmetry. I highly recommend you sketch it out on paper and maybe send me those sketches. And then you also want to try and explain those lines somehow. So I did my best explanation here. If I didn't think my audience would understand perpendicular bisector, then I have to come up with another explanation of that. And so I'll do that next time. All right, so once you get each of those done, then we're going to broaden and come up with creating our own figures. So I'd like you to use the pattern blocks again, but I would like you to use at least 2 pattern blocks to make a new figure that has some symmetry. So it should have at least a line of symmetry and maybe a rotational symmetry, if not both. It doesn't have to have both, right? Because this figure right here, let's see, it has 2 lines of symmetry when I draw them in like I did before. It has 180-degree rotational symmetry. I could make a shape kind of like my butterfly out of these pattern blocks. So let's do that. So I just want you to play, have a little fun with it. If you have a kid around, have them play with you. So what if I started with the square, and let's kind of rotate it a little bit. And I don't care which tool you use. I link out to both of the ones I liked from before. So if you like this other one better, feel free to use it. And the nice thing about this one was that you get this little rotational doodad on there that you can pull it around, and that if you put 2 of them next to each other and they're rotated properly, then if you set them just on top of each other, they kind of snap into shape. And these other ones, you're gonna kind of push them into lining up. So let's suppose I make this shape here. So this is my little quadrilateral butterfly. Can you see it? Oops, get right where I want you to be. Come on. Oh, well, it's stuck there. Okay, so it's roughly in the same spot. So does this shape here have any symmetry? And so I would trace it on a piece of paper. I'll bring in my board, copy. So you could get really wild and use 5, 6, 10 of these if you want. Let's see, add to current page, please. Oops, no, wrong page. X, new page. There we go. All right, so what does this have for symmetry? Well, I can draw a line, which I think would go through, let's use red, about here-ish. All right, so that's my best guess at its line of symmetry, so that this side of the line mirrors that side. So it definitely has a line of symmetry, and I don't think it has any other lines of symmetry. So if I tried to draw another one kind of perpendicular there, not a mirror top and bottom, nope, so that doesn't work. If I try to connect some vertices to make a line of symmetry, which happens sometimes, like maybe this one to that one, nope, what's on one side of the top of the line is not symmetric to what's on the bottom. So no matter how I play with lines here, and sometimes I do, it's not obvious to me, and sometimes it is, depends on the day and the figure. So I don't think this has any other lines of symmetry. All right, so one line of symmetry, splits vertical. Okay, and does it have any rotational symmetry? So that you actually have to kind of draw it and then rotate your paper and see when you get the exact same thing again. And, you know, nope, 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 it's upside down there. Okay, nope. All right, so this has no rotational symmetry. That's okay. What I don't want to have happen here is you draw 3 different figures and they each have 1 line of symmetry and no rotational symmetry, right? That would be kind of boring. So I want you to play here and explore a little bit. So in the second part, I would like 3 diverse shapes. So have fun with this here, make something interesting and beautiful, and then explore its symmetries. And again, you could even come up with a shape that's beautiful and not quite symmetric at all. Like, I don't know, what could I do? I could put that guy up there. And then I could grab another one and stick them down here. So I could use like an equal number of shapes. So kind of thinking about, you know, the whole tessellation kind of thing. Which side should I put that on? I think I'd put it right there. Might that tessellate? Is there any symmetry to it? I don't think this has any lines of symmetry, and I think I'd have to rotate it 360 degrees. So this does have some kind of symmetry in that I have this orange thing in the middle, and then I have blue, green, orange, blue, green, orange, but there are no lines of symmetry and there's no rotational symmetry to this thing. Okay? So, you know, that's something you could put in here. But I would like something with multiple lines of symmetry and some rotational symmetry also. So play, have fun, and I'll show some more next time. All right, I'm going to shut up now. We will continue with this activity next time. My hope is you worked on it, some in between. And then the next activity is kind of like last week's, where I want you to look around your environment and find me something cool. So I would like you to find me a cool 2-dimensional object that has some symmetry to it and tell us about the symmetries. So if you could include a picture, that would be delightful. And then find a 3-dimensional symmetric object and post a picture of it describing its symmetries. So I will just give one example of the 3D stuff, and then I keep saying I'm going to shut up. So I guess I better. Okay, I'm going to shut up. And I guess I'll show this next time. So take care, do good math, get caught up, and enjoy your family and your quiet time alone, if that exists. Bye-bye. I love it. Thanks, Giselle. You rock. Hello, world. It's me. Goodbye.